But 4.5 billion years ago, Earth looks more like hell than home. Up close, the temperature is over 2,000 degrees Fahrenheit. There's no air, just carbon dioxide, nitrogen, and water vapor. It's so hot and toxic that if we got any closer, we'd be incinerated and suffocated in seconds. This newborn planet is a boiling ball of liquid rock. An endless ocean of lava. A young planet called Thea is heading straight for Earth. The size of Mars, it travels nearly 10 miles per second, 20 times faster than a bullet. Jupiter's gravity distorts the Earth's surface. The blast wave races around the planet. It's as though both young planets turn to liquid. But over the course of 1,000 years, gravity turns the rubble into a ring of red-hot dust and rock that circles the Earth. From this ring, a ball forms, over 2,000 miles wide. It's the birth of our moon. But it's much closer than the moon today. Just 14,000 miles away, instead of 250,000 miles. The sun rises over a cooling Earth and sets just 3 hours later. The Earth is spinning so fast that an entire day lasts 6 hours. The days may pass quickly, but the Earth changes slowly. To understand the making of our planet, we need to fast forward through millions of years. $3.9 billion years ago, a hail of meteors attacked the Earth. It's debris left over from the solar system's formation. Inside the meteors are crystals that look like grains of salt. And inside the crystals are minute droplets of water. These deadly missiles could contain the vital ingredient for life on Earth. Only a small amount of water exists inside each meteorite. But as they bombard the Earth for over 20 million years, pools of water grow. The Earth's core remains molten, but its surface has cooled enough to form a crust. The air is around 170 degrees. In the future, there's a chance we could swallow this very water. Every sip, every puddle, every drop of water in every ocean is billions of years old. And it may have traveled millions of miles to reach us, carried inside a meteor. The Earth looks more familiar, but it's still a dangerous place. Winds are faster than the most destructive hurricanes today. It's a megastorm, whipped up by the planet's rapid rotation. The moon is so close to Earth that its gravity is overwhelmed, creating huge tides that race across the planet's surface. But over time, the moon moves away, the waves calm down, and the planet spins slower. "700 million years after the planet's birth, life-giving water covers its surface. And scattered throughout are tiny islands. They seem to have appeared from nowhere. So how did they get here? Molten rock bursts through the Earth's crust and rises up through the ocean. Over time, the lava cools, forming a volcanic island. In the future, these islands will join together to form the first continents. Earth now has water and land. It's beginning to look like the planet we call home. But the atmosphere is still toxic, and the temperature is scorching. Life here is impossible. Since the planet's formation, meteors have been pummeling Earth. But now, 3.8 billion years ago, the assault enters a violent new phase. Some things disturb the orbits of these meteorites. In addition to water, the meteors carry something else. As they dissolve, And this magical transformation releases a byproduct, a gas called oxygen. Underwater, the stromatolites slowly fill the oceans with oxygen. The oxygen then turns traces of iron into rust, which fall to the ocean floor to form deposits of iron-rich rock. It's this mineral that will one day be used to build bridges, ships, and skyscrapers. Above the waves, the oxygen transforms the atmosphere. These stromatolites are creating the most important element for life on Earth. Without them, virtually every living thing wouldn't exist. Over the next 2 billion years, oxygen levels continue to rise. And as the planet's spin slows, the days get longer, lasting at least 16 hours. $3 billion years after beneath the crust. These movements push and pull the plates around the globe with them. Millions of years race by. Our planet is alive and changing. Over 400 million years, a vast new supercontinent takes shape. It's called Rodinia. In the shallow waters surrounding Rodinia, stromatolites work their magic for more than 2 billion years, pumping oxygen into the atmosphere. The temperature is 85 degrees, and the days are 18 hours long. But this planet looks more like Mars than Earth. To find life, we must fast forward through time. Washington State, 750 million years ago. A force deep inside the planet rips the crust to pieces. It's as though the world is breaking apart. And there's only one force powerful enough to do this: heat. It escapes from the Earth's molten core, stretching and weakening the crust. Inch by inch, year by year, the great supercontinent is splitting in two. The intense geological activity spawns a mass of volcanoes. They pump carbon dioxide into the atmosphere. The carbon dioxide mixes with water and creates acid rain. When the continent tore apart, many rocks were exposed. These rocks absorb the acid rain, including its carbon dioxide. Vast quantities of CO2 are absorbed out of the atmosphere. Now, there's not enough carbon dioxide in the air to trap the sun's heat around the planet. In just a few thousand years, the temperature plummets to around -60 degrees. This frozen wasteland is southern Australia, 650 million years ago. It's the start of what some scientists call Snowball Earth, a period they believe to be the longest, coldest ice age ever to grip the planet. A vast wall of ice looms thousands of feet high. And it's unstoppable. The more ice there is, the more sunlight it reflects away from the planet, and the faster the ice spreads. Nearby is a second ice sheet, just as high. The two sheets spread